Let's see if anybody remembers this from before. The percentage in a normal curve there's something called the empirical rule. So at the end of section 2.7. For normal distribution within one standard deviation, there's a certain percentage known to be in there. Let me just give it to you unless somebody knows it. 60, 65, 60, 60, 68. I love you guys. Yeah. One of the prices are right. Higher, lower. Within 2 steps, there is known to be 95%. So now you really start to see why we call outside of 2 steps, outside of 2 standard deviations, is unusual. Because how much data is outside of 2 steps? If there's 95% inside, there must be on each side, so there's a total of 5% outside. There's only a 5% chance of being out here. So real quick, men's heights are known to be normally distributed with a mean of 69, I think, and a standard deviation of 2.5. Let's make it 2.5 to make this easy. So for American men, right? Other countries, some are taller, some are shorter. So what is this? The mean is 69. What's this?
Maximum.
No. That would be this.
71.5.
Yes, it's 1 step up, right? It's 1 standard deviation up from the mean. Is that cool? That's what that means. That's the z-score of this thing. So what is it in height-wise? It's add 1 of these to it. 71.5. So what's this?
24.
Add another 1.5, so you end up at 70. I appreciate you, though. You're the only one saying anything, so that's good. If you can get it wrong, I'll still be happy. And if I go the other way, 1 standard deviation below the mean. Oh, wait, it's 2.5, so you got 74. You're on. So maybe I should give myself the day off. So if we go down 1 more, this will be 60. 66.5, and then this will be 64. So am I, apparently, so don't feel too bad. Alright, so it makes sense because 2 steps should be 5, right? If 1 step's 2.5, 2 steps should be 5. Cool, I like it. So what does this mean then? What percentage, and this is, by the way, this is men, right? I don't know if I said that, I think I said that. U.S. men, what percentage of U.S. men are between 64 and 74 inches tall? 95%. Because we know that heights are normally distributed. That's why. If I know that the heights are normally distributed, I know all the probabilities. They're all in that chart I just gave you. Right? So a huge part of statistics is what I'm looking at normally distributed? If it is, holy shit, I got all the answers. I just got to look them up. I got all the freaking answers. We're going to talk about how the hell they use this thing to get the answers. If it's not normally distributed, shit, then I actually need stats too, which we don't teach here, sorry. Right, so what's going to happen most of the time this semester is we're going to be dealing with normal distributions, right? Thankfully, it does happen very often with procedures we use that we do have something that ends up being normally distributed, so it's not an uncommon thing. Okay. Let me ask you this. What percentage of men are more than 74 inches tall? So what percentage are outside of here? 5%. So what percentage is up there? 2.5%, 11. So if I wanted to have at most 2.5% of the male population have to duck when they go through the door, I would make it 74 inches tall. I think one semester I actually brought a meter stick and we measured it. It was 76 inches tall. So they just went, let's just make sure almost nobody has to duck. Do you see what I'm saying? So this kind of thing you can control, you can say, well, how many people do we want to be angry at us? How many people are we okay? That's like now we're getting in closer to another situation where the airlines could use this. What's going to be bad PR? If more than 3%, then we want to set something here. Right? We want to be here. Or if 2.5%, we can be right there. And only 2.5% of people will be angry at us. Maybe this is wait times. They have to wait longer than they wanted to, and they'll be angry at us. So you guys kind of understanding here. If I want the door, if I want more people to have to duck, then I can make the door this tall, whatever that is. And have 10% of the people have to duck through the door. Ha ha ha, right? I'm sorry.
Is there a question like, what's the outlier or anything?
Yeah, so again, this is kind of explaining why this, u plus or minus 2 sigma, this is our boundary between usual and unusual. Yeah. So right now, anything out here would be considered an outlier. Unusual, yeah.
Okay.
Outlier. I was thinking about children cord when I say outlier. Outlander, we have you. Of course, nobody wants it, so it's okay. So, what we're going to do, first thing I want to do, is to use this chart to get these numbers, just to see that this chart even is true. If we don't get those numbers, we can throw this out and we can go home. I love it. Whenever I say it, somebody's like, please let him make a mistake. I'm so freaking out of here. Alright, so here's how to read this. Look at the top of the chart. It tells you what's happening. So when I look up a z-score on this chart, and I will show you how to do that, it will tell me the area below that z-score. So for example, if I look up -2 on this chart, however I do that, it should be equal to what? What's out here? We know what's up here. It's the same amount down there, right? What's out here? 2.5%. Should be 0.025, roughly, right? So let's try it. Let's see. Can we look up -2? So how do you read this weird shit? These are z-scores out here. This is the first 2 decimal, right? I'm sorry. First 2 digits, 1 decimal. This is the second decimal. So that's why z-scores, we normally get around the 2 decimal places, because that's how far the chart goes. So if I want -2, so see how there's a negative side and a positive side, so please make sure you're on the negative side. -2.00, that would be -2, is that cool? If I wanted -2.01, I would go here for -2.01, but I want -2.00, and I get 0.0228. Which is decently close to 2.5%, right? Maybe not. Let's try this. So how would I get between -1 and 1? This is going to be a little bit harder. So let me draw this picture here. Oh yeah, you should be facing that way in a minute. Okay. So if I want between -1 and 1, remember the only thing this chart can do, is tell us areas below the z-score we looked up. So if I want this area, that's the area I want. I can't get that area directly from the chart, because that's not what the chart does. It doesn't tell me areas between. So what the hell? If I look up 1, can you guys try to look up a z-score of 1? Try to look up a z-score of 1. See what you get.
15399.
Uh-oh.
0.8413.
Yes.
Oh,
1.00. Yeah. Good try. I like it. You said with confidence.
0.8413.
All right. There you go. Where is that now? Please, dear God. We're just starting out here, but to be nice to yourself, you draw the picture, and the minute you look up a z-score, you put that up here on the chart. Z-score is down here. Area is up here. So we just looked up 1.00, right? So that area is the total area below. So that was 0.8413.
Is it always below, never above?
Always below. That's the way the chart's set up.
Okay.
Yeah. I like it. Now, so that's too much, right? That's too much. I only want this much. So I have to subtract some off. How much do I have to subtract off? Well, exactly this much. So if I look up -1, yeah, 1587. So physically, does this make sense? That's too much. If I cut this much off, I'll end up with the answer. So I want to subtract those. So anytime I want between two z-scores, I'm going to have to subtract areas. So what is 0.8413? Minus point. Point who?
6826.
And what's it supposed to be? 68%. So that's fine. All right, that was a little more impressive, I guess, than the other one. So the empirical rule is a quick rule of thumb. They just give you rounded off numbers and say it's exactly this. And in reality, they're sort of 6826 instead of 68. Right? So, all right. So let's do a couple more. And please, dear God, let me know if you're having any trouble finding these numbers right now, because today is the day to really get this down. This is how to use this chart. Figure out what the probability that z is greater than 1.29. Let's see how to do that. We'll do this one together. So if I'm given a problem, trust me, especially when you're first starting with this stuff, you want to draw the picture. There will be people that don't draw the picture, and they will be the ones that make really stupid mistakes. So don't be stupid. Where's the mean and what is it? Where's the mean? And what is the mean on the picture? It's in the middle. I like it. And it's equal to what? 0, because I got z-scores, right? I like it. And real quick, before I get too far, I'm obviously implying that this is a normal distribution, but the z-score chart only works if it's normal. If it doesn't say it's normal, oh shit. And I want greater than 1.29. Now, please, dear God, for some reason, people don't put this number in the right place. This is just a number line. Where's 1.29? It's going to be up here. Some people just kind of throw it up there and they think, it doesn't matter. But if I put it in the right place, about right there, it doesn't have to be perfect, but it's on that side. Which way am I going to shade now? What's the question asking for? The area that's where? Greater than. In fact, it's an arrow pointing you in the direction you shade, right? Greater than. So it's that way. I want this little area. So I know my answer is going to be less than 50%. It is certainly less than half of this image, right? So if you draw the picture correctly, it will help you get the right answer. Now, if I look up 1.29, is that going to be the answer? Hell no, but we got to do that anyway. It's the only. So what do you get when you look up 1.29? So let's make sure I'm going to do this up here too. So if you're having any trouble and you don't want to speak up, here's 1.2. It's positive, so I went to the positive side. 1.2 and 9 is 1.29 is right there. 0.9015. So then the action is that I know that's not my answer because I was smart. I drew the picture, I shaded my answer, and that ain't my freaking answer. So I'm not going to circle that and keep going. I'm going to go, shit, how do I get this? Yeah, good, because the whole picture is 1. So this will be 1 minus 0.9015, 0.0985. Now, is everybody, how do you feel about that? So the chart only tells me areas below a z-score. So if I want area above a z-score or between a z-score, I'm going to have to do some adjusting, right? Just to point out a shortcut. All I'm going to say is what I'm about to say right now. If you don't understand the shortcut, never try to use it. It's sort of like the blinkers in your car. If you forget about them sometimes, just don't use them. Look up negative 1.29 on the z-score chart. Because the area here has got to be the same as the area there, if you think about it, right? Because the normal distribution is symmetric. So whatever area is over here has got to be equal to the area there. If you don't quite get that shortcut, like I said, never use it. It's not really the best shortcut. You shaved off like 2 seconds. Good job. You know? But still, it's a decent shortcut to know if you understand it. If you don't understand it, don't use it. It's not necessary. So, turn this sheet over. I think for today, I'm going to let us out a little bit early. Don't get excited. I definitely want everybody to get 1A through E done. Because, of course, the next problem after that is number 4. I love that, Chef. That's awesome. Number 1 and then number 4. We haven't even talked about how to do that yet. So 1A through E. Try to do those. That's just directly using the z-score chart. Yeah, you don't need a calculator at all for, well, I mean, you can use it if you want to do 1 minus stuff. Did I show you guys a shortcut for 1 minus decimals like this? So watch. This is how it always works. Make everything 9 except the last one. So how do you make 9, 9? 0. How do you make 0, 9? 9. How do you make 1, 9? 8. Do you see what I'm saying? Think about what you add to make a 9, and then make the last one 10. Now some of you guys are going, I got a great shortcut right here, Jeff. Alright, whatever. That's kind of really, really useful. So if I wanted to do like 1 minus 0.3294, 6 makes this 9. 7, 0 makes it 9, and then make the last one 10. If you think about it, you're figuring out what you have to add to make it 9999, so if you add one more, that'll make it 1.000. That's why that shortcut works. Alright, I'll stop.